Hello, a pleasant afternoon to each and every one of you, and it is my honor to conduct to you a brief lecture about the matters of our universe. So this video is entitled, A Matter of Fact, Unweaving the Canvas of Our Universe. So the first question is matter. What is a matter? So matter is the recognizable term for the atoms and molecules that constitute the components that make up our physical reality. Anything with mass is composed of matter. We identify these elements as existing in states, which can be referred to as phases at times. So these books, the soda, balloons, boats, wood, milk, the factory and its smoke and the ice cubes are all made of matter. The only question is at what state are they made? So the three states of matter that are most generally known are the solid, gas, and liquid. However, there are two other states that are less well known but equally significant, the plasma and bose-einstein condensate. So if we're talking about unweaving the canvas of our universe, it is important for us to at least talk about plasma, then I'll add up on the bose-einstein condensate. So the states of matter, out of many states recognized in other articles, only 5 of them are going to be discussed in this very short lecture. So the first basic state of matter is the solid. So as we all know, solids is where atoms are packed close to one another to prevent movement. So what does that mean? So for other states of matter, the atoms these atoms tend to vibrate, but it's not the case for solid because there is no room for the atoms to vibrate because of how closely packed they are to one another. Solids are not easily damaged by pressure because of this distinct feature they have. So, to brief on about the liquids. So, the atoms of liquids are packed as close as a solid, which allows it to conform to the container or shape it's been put. So, what they're saying is, although its atoms tend to be similar to those of a solid, what makes liquid distinct is their volume. Their fluidity makes them incapable of being compressed, so they only follow the shape of the container they're being put in because of their fluidity. But in actuality, they cannot have a shape of their own if not because of those containers. So next we have the gases. So in gases, the atoms are much more spread out than in solids or liquids, and the atoms collide randomly with one another. So what makes gases different is how their atoms are not packed together, giving them a tendency to float away from each other. They have no set shape, no set volume. Right now, you are probably, of course, breathing in air. So the air you're breathing in is a mixture of gases containing many elements, such as oxygen, nitrogen, and carbon, but you can't actually see them because, again, they have no set shape like liquids if you put them in a container, or they have no set volume like the solids, which you can actually feel the weight when you touch them or carry them. So now let's move on to plasma. So as I've said, this is a fourth state of matter that makes up most of our universe, although they are not really the most common state of matter in our very own planet. So in Earth is, as I've said, is not a common state of matter, but for the whole universe, it is deemed that it may be the most common state of matter. So in plasma, when atoms are energized, a substance known as plasma is created. So atoms are generated with have a high amount of kinetic energy, which means they are highly to vibrate more than the other states of matter and they are highly charged, which makes them energize atoms, creating plasma. So they emit light because they are so ecstatic that they transcend an energy level. So gas and plasma are extremely similar. In fact, the simplest way to think of plasma is as a gas with the ability to carry an electrical charge. So is it is like a gas but with an electric charge. So yeah. In contrast to gas, plasma is made up of randomly arranged particles that carry some free ions and electrons, which allow them to conduct electricity. So, although they are not the most common state of matter on Earth, they can still be discovered in some types of fluorescent lights and neon signs on Earth, like this one. And on Earth, lightning is also another type of plasma that forms during storms. And another type is the aurora, which occurs when particles from space interact with atoms in the upper atmosphere. And of course, the most common form of plasma. So, as I've said, it is the most common in the universe, so it can be found in the star, and it is found in the big star of the universe, like the sun. The sun exists in the plasma state, and in general, 99% of the observable cosmic environment is composed of plasmas, which are most prevalent state of matter. So, so we have the sun, the neon signs, lightning, and the aurora. So moving on to the bose-einstein condensate. So as I recall from high school, it was not really mentioned when I was in high school. So I'm hoping that this may be new knowledge for those who are watching right now. So before acting as a single wave and ultimately uniting to form a superatom, the atoms begin to behave like little waves and overlap one another here in Bose-Einstein condensate. So this is the fifth state of matter I will be discussing now. So Bose is actually an Indian physicist and mathematician who was studying the relationship between light and temperature through advances in quantum theory. So that's very technical, but the Bose-Einstein condensate was actually created when particles called boson are cooled to near absolute zero, so specifically negative 273.15 degrees Celsius, and they are found to exist not only in ultra-cold atomic gases, but also at higher temperatures in materials hosting bosonic quasi-particles such as magnons, excitons, and polaritons. So you can search on that later because that's very wordy. So they have merged into one entity. So those with the same attributes and they are coexisting in the same location and they are put to a very cold, very high temperature, absolute zero, near absolute zero. So they have merged into one entity, making them unidentifiable from one another, which made them call it a superatom. So there are many other states of matter already found, but the molecular arrangement of these states of matter is what initially makes them distinct from one another. Their molecular arrangement, as can be observed for the rest of this video, can be caused by certain factors like this. So the changes in matter, how are they possibly changing their state? So what makes solid only, or can it be turned to liquid? Yes, we all know that it can be turned to liquid and liquid can turn to solid as well. But what are the factors that makes them uh, the state of matter they are? So the changes in matter are mainly caused by temperature and pressure. So temperature because these cause molecules to either move faster or slower, while pressure, it can cause molecules to become more or less packed together. So the last part of my brief discussion about the states of matter is how did the world benefit from understanding these states of matter? So the first one is food science and preservation. So techniques in food preservation can be developed by comprehending the effects of temperature and pressure on the state of matter. For example, refrigeration and its cold temperature keeps food in a state where bacteria are less active, slowing down the growth of these harmful germs or um, beings. By converting the water content of food into ice, a solid form that prevents bacterial development, prevents the food from becoming spoiled and having bacteria. So this is, in other words, is being freeze for preservation. The next one is advancement of energy technology. So understanding the state of matter is crucial for developing efficient and effective energy technology. So here we can see a solar panel. So the solar panel relies on the solar power of the sun's energy, which is in the form of a state of matter called plasma, as we discussed earlier. So the hot, energetic plasma state of the sun is the ultimate source of the light energy that solar panel converts into electricity for a house or anything. So another example is the power plants themselves. So power plants rely on the fact that water expands dramatically when it turns to steam or gas to drive turbines. So understanding the behavior of the gases at the high temperatures and pressures is essential for designing efficient and safe power generation systems. The third one is the development and innovation of materials. So en- engineers and scientists can create new materials with certain features by having a thorough understanding of the characteristics of gases, liquids, and solids. So numerous inventions have sprung from this, including flexible electronics, lightweight materials for construction, and other durable materials used for engineering and construction. The fourth one is uh, manufacturing processes. So, understanding the states of matter, the effect of temperature and pressure actually improve manufacturing processes. So, the specific example for this is the melting metal to a liquid and then pouring it into a mold to solidify into the desired shape known as metal casting. But here in the picture, we can see the example of creating glass from sand and high temperature, high hot temperature. So glass blowing is the process of heating glass, which is solid until it melts and becomes liquid, allowing it for shaping. So from sand, there is heat applied, turning it into glass, and then the glass is melted further to so the creator can mold it into shape in relation to the state of matter. So material transformation into various states is a common step in industrial processes. And lastly, uh, the the last benefit that I could share but from studying the state of matter is the forecast of weather, which we are which we can see in the news and we can hear in the radio. But these coloring right here are actually results of um, studying the behavior of gases in the atmosphere, which might affect weather patterns, therefore um, allowing people to know or what to expect with the upcoming days and how are the weathers of them will be. And weather patterns can be predicted with the use of knowledge of how temperature and pressure affect the airflow and the overall weather of different countries, different provinces. And, and, and that's all. Um, my short video about the states of matter will be ending here. So thank you for listening and for unweaving the canvas of our universe with me.